Yeah, hi everyone. Today's video is going to be a bit of an extension from expanding brackets using the distributive law. I'm going to be expanding brackets, but I'm going to be expanding binomial products, which basically means I've got two sets of brackets side by side, and I'm going to expand them using what I call the FOIL rule. Now, the FOIL rule, or the word FOIL, is an acronym, and the F stands for firsts, or the first term, O stands for the outer, or the outer terms, I for the inner terms, and L for the last terms. So I'm going to multiply the first term in each bracket, the outer term in each bracket, the inner term, and the last term in each bracket. And if there are any like terms at the end, I'll collect those. So let's go ahead and jump straight to example here. I've got example 2a from the textbook, and my first bracket has x plus 5, and in my second bracket I have x plus 4. Now, using the FOIL rule, what I want to do is multiply to start with the first term in each set of brackets. So in this case, it's x times x, which is x squared. So that's the first term done. Then I'm going to multiply the outer two terms from each bracket. So the outer terms are x and positive 4. So x times positive 4 is plus 4x. Then I'm going to do the inner two terms. So the innermost terms here are 5, or positive 5, and x. So multiply those two together to give me positive 5x. And then I'm going to do the last term from each set of bracket, which is 5 times 4, positive 20. Now I'm at a point where I've got four terms, 1, 2, 3, 4 in my expression. These two terms are what we call like terms. And in a previous video I've spoken about this. We can collect that, or those two terms, to simplify this expression, which leaves me with, let's go back there, sorry guys, which leaves me with 9x, or x squared, plus 9x, plus 20. Okay, so expanding using the FOIL rule, and then collecting like terms if there are any. Okay, so that's the process we'll be doing today. Now, let's go to the second example there. I'll run through a few examples. Just take what you need, guys, today and get started. But basically, this second example we're looking at is what we call a perfect square. Essentially, it's just one bracket squared. I can write that as a binomial product. So x take 4 squared is actually x take 4 times by x take 4. And then I can use my FOIL rule. So the first term in each bracket is multiplied. Then the outer term in each bracket is multiplied. Let's use yellow. So x times minus 4 is minus 4x. Then the inner terms, minus 4 times x, again, minus 4x. And last terms, minus 4 times minus 4 is positive 16. So I'm left with, again, four terms here. I can collect those terms if there are any like ones. Of course, minus 4 and minus 4x, well, minus 4x and minus 4x are like terms. So minus 4 take 4 is minus 8x. And there you go, simplified expression. There is a bit of a shortcut going from a perfect square to the final expanded, simplified expression, and I'll show you that in another video. But for today, guys, I just want you to use the FOIL rule to expand these brackets. The last example I'm going to show you here is actually what we call a difference of perfect squares, or DOPS, it can be referred to for short. Difference of perfect squares. It's 2x plus 1 in this case, and the second bracket is the same, but instead of plus 1, it's take 1. Okay, that's the difference of perfect squares. Again, we're going to use the FOIL rule first, which gives us 4x squared. Multiply those two first terms, then we multiply the outer terms, then we multiply the inner terms, and then we multiply the last two terms, and then we collect like terms. So in this instance, you'll actually see that minus 2x, positive 2x are the like terms. Minus 2 plus 2 is actually 0. So those two actually cancel each other out. We're then left with an expression that only has two terms. So 4x squared, take 1. Again, there is a bit of a shortcut when you're going from difference of perfect squares to the final simplified expanded expression. I'll go through that in another video, but for today, the FOIL rule will get you there as well. Alright, like I said today, guys, just take what you need, and if you want to stop there, use this as an example of a bit of a blueprint. You think you're okay, get started on the questions if you're in my class. Otherwise, I'm going to go through a couple more, I guess, complicated examples, and I'll jump straight into those. So let's look at the first one here, example 3a. I've got 2x, take 1, 3x plus 5, and I'm not going to show you the arrows this time. I'm just going to do the first two terms. 2x times 3x is 6x squared. Then I'm going to do the outer term, so 2x times positive 5 is positive 10x. Then the inners, and then the lasts, and then collect my like terms, these two, which gives me a final solution of 6x squared plus 7x, take 5. Okay, hopefully you followed that there, using the for rule to go from here to here, and then collecting like terms to go from here to here. Alright, second example, this time is a little bit different because we've actually got, when I write this expression, we've kind of got a bit of a combination of the distributive law and the for rule. So I've got a binomial product in terms of this, well, these two sets of brackets, so x take 3 and x take 2, but in front of them I've got this term as well. So what I'm going to do is I'm going to use the FOIL rule to sort of work on expanding these two brackets first, and then I'm going to use the distributive law to multiply the term in front by each term inside. But let's sort of get to that. Let's use the FOIL rule to expand both these brackets first. So let's do, let's get the 2 there. So x times x is x squared, x times minus 2 is minus 2x, minus 3 times x is minus 3x, and minus 3 times minus 2 is positive 6. Now I'm actually going to collect those like terms before I go any further here, so that gives me minus 5x plus 6. Now I'm going to use the distributive law to multiply the term in front by each term inside. So 2 times x squared, 2x squared, 2 times minus 5x is minus 10x, and 2 times positive 6 is positive 12. Alright, the last example I'm going to show you guys is two sets of binomial products, and this can be a little bit tricky. So bear with me here as I go through this one. Let's write it out. So x plus 2, let's do that again, x plus 2, x plus 4, take x take 2, x take 5. Now, I'm just going to work on the first pair of binomial products and then the second pair of binomial products. But I'm going to leave them inside brackets, and I'll tell you why in just a second. So let's just do the for rule on those first two brackets. So that gives me x squared plus 4x plus 2x plus 8 take x squared, take 5x, take 2x plus 10. Alright, using the for rule I've just expanded that set of brackets, or those set of brackets there, and these set of brackets here. Now, the reason I've left them there inside the brackets here is because of this minus sign. That minus sign is actually a minus 1. Now I'm actually going to then minus or multiply each term inside this bracket by negative 1. Okay, that's the confusing part. So that's why I've left them in those brackets. Let's just do it that way because I've said I'm going to do it that way. You can collect these like terms if you want first. It'll still give you the same answer, but let's just go ahead and do it by multiplying the term in front of the bracket by each term inside the bracket. What's in front of this term? Here. What term is that? It's a positive one, isn't it? There's nothing there. We assume it's a positive one. So each term inside this bracket can be multiplied by positive 1, which still gives me 1 times x squared is x squared, 1 times 4x is positive 4x, and so on. So I'm going to remove those brackets easily. Then I'm going to multiply each term inside this second set by minus 1. So minus 1 times x squared is actually minus x squared, and then minus 1 times minus 5 is positive 5x, minus 1 times minus 2, positive 2x, and minus 1 times positive 10 is minus 10. Now I'm going to collect any like terms I've got here. I've got lots of terms. I've got 8 terms in total. One like term with another like term here, like term here, here, and here, and 2 constant terms here and here. So if I collect all those terms, starting with x squared, take x squared, well, that's cancelled out. There's no longer any x squared terms. 4x plus 2x, 6x, plus 5x, 11x, plus 2x is 13x. So 13x, and then I've got positive 8 and minus 10, plus 8 take 10 is minus 2. So all that work, we're left with an expression that has 2 terms, which is 13x take 2. Alright, so hopefully that made sense, guys. Like I said, probably take what you need from this to get through the questions today. We've had a bit of a look at perfect squares, difference of perfect squares, but essentially use the FOIL rule, okay? Use that acronym to help you expand those binomial products and then collect any like terms to simplify those expressions. Alright guys, thanks for watching and good luck.